Hi, myself Divyanshu, and I'm going to present this AI project named Malware Detection. So basically, this project is based on malware detection, where we are going to detect the malware in the files. There is a data set where we have created a data set where the benign file and the malware file both are presented, and we we are training this model to generate the correct result to correctly identifying the malware files. So we are not using the real malware here. This is just a proof of concept for the malware detection AI model, and so we are creating a data set by own, and we are showing the proof of concept on it. So now I'm going to explain the code snippet here. Uh, so we are uh, importing the pandas and numpy as panda library used for handling structured data like tables and data frames, and numpy for numerical computation, uh, working with arrays and random number generation. So basically, we are going to generate our own data set. So these are important library for that. Uh, Below, we have created a function generate synthetic dataset. Samples is equal to 1000. Uh, the sample size is 1000, and uh, the total data points are 1000. And then we have given np.random.seed42. So the random seed is 42 to ensure that random number generated are reproducible every time we run the code. So basically, and then we are generating the malware data. So malware size equal to np dot random normal. Uh, uh, Size samples by 2. So we have created 1000 data point sample, and we are giving it malware at 500 data point, 500 data points, and LOC is equal to 4000, meaning the size of malware file is 4000 units. The scale is 500, means it can be plus minus 500. The standard deviation of 500 units can be here around the mean. So this is it. And then there is malware entropy. These files have an average entropy of 7.5. uh, the high entropy indicates more randomness. So it is a common factor of malware. So the common factors in the malware file is like big size and more entropy, more randomness, so they can evade detection. So we are taking those two features here. Then we are selecting the scale zero point 0.5 standard deviation. Uh, Entropy can be slightly vary here, and then we are labeling this label as np dot once, mean the malware will be presented by one. uh, all malware samples are labeled as one here. So then we have created the benign file size, like benign data. So np.random loc 1500. So we can see the data site difference here. In the above code, malware size equal to np random normal loc equal to 4000, and here we have only uh, 1000 around LOC. So this is the common difference between a benign and a malware file, and then the scale is 300, and also it is the remaining part of our data point like 500. Then we are creating the entropy here. Uh, So these are authentic files, so it has lower randomness like 5.0, and it can be deviated 0.5. So we are labeling this level as 0 in the next line when I labels equal to np dot 0 samples by 2. Then we are concatenating these files in the merging these file into the single arrays size, like combined file sizes and entropy, combining the entropies. And we are labeling here one for malware and zero for benign files. Then we are creating the dataset pd.data frame size entropy label and returning the dataset. So this is the pandas data frame. It will create like an Excel table in is created with three columns like size, entropy, and labels. And then we are generating this and returning the dataset. Uh, then dataset equal to generate synthetic dataset. It is calling it 1,000 samples, and the dataset head it shows the basically we are giving the dot head, so it will show the head of the data set, like 5 rows of the data frame. So five or four, yes, 5 rows of data. So here is the data. So we have created our data set. Now we are uh, plotting this data set, like importing Seaborn as SNS and Matplotlib, and we are showing the label how this is going to look like. So this is the chart for that. And then now we are going to modifying this dataset for model. So basically, uh, the data set we have created, it is not in the standard size to train for creating a neural network. So first we are going to create uh, we are going to split and scale these data set, and then we are going to give in machine learning pipelines. So for that we are importing the scikit library and train test split and a standard scalar for that. And then we are labeling the data set in x and y. X is features as we know, and y is target. So then we have created these x features and y target. So x are independent variables. The actual input is here, like size and entropy, and target is like 0 and 1, 0 for benign, 1 for malware. So this is label, basically dataset label. And so it will look like something like x is equal to in the numpy format. It will look like x is equal to bracket bracket size 1 entropy 1, size 2 entropy. So this will something look like this. And in the in the in the target array, it will look like level 1, level 2, and level 3. Then we are standardization. We are doing here scalar equal to standard scalar. We are doing standardization of the data, basically feature scaling. Actually the machine learning models, these model works best when features are on similar scales, like like size values are 1500 to 15 1000 to 400, and entropies are like values are 5 to 7, 7.5. These are very different scales, so this can bias the model. So that we have to feature the scale. We have to do feature scaling and the standardization of the data. So what this standard scaler do? Uh, it will a scale feature, it scales feature so that the mean of it becomes 0 and the standard deviation is 1. And then we are giving the scalar dot fit transform x. uh, so fit so what is going on here is it calculates mean and standard deviation for each column, and then transform using the math formulas. Uh, so uh, and then it is x train x test y test equal to train test split it. So it divides the data into two sets, like training set and testing set. So it is 0.2. So 80% of data is used for training set and 20% for testing set. So here that is happening. So X train is like training features, X test are like testing features, and then Y train are training tables, and Y labels and Y test are like testing labels. So this is what happens here. And then we are going to build our neural network now. So basically we are going to use three layer neural network. There we are using the sequential form. So in the first layer, this is input plus hidden layer 1. We are creating 16 neurons, and the input dimension is 2 because there are two input features like size and entropy. And then we are giving it activation, rectified linear unit activation, where function is max to 0 to x. And then in the second layer we are taking 8 neurons, and then again using the value as a activation function. It will add the more complexity to learn the patterns. And in the third layer, it is a output layer. So it is one neuron, because it will predict the output. It will predict the basically label. Is it benign file or a malware? So as a function activation, we are using sigmoid. It will express the output in between 0 or 1. So it is for it is like binary classification. So function for is for it like 1 by 1 plus e to the power minus x. So this is the final output will be interpreted as the probability of being a file, a malware or benign. So uh, then we are compiling the model.compile, where we are using the optimizer as adaptive movement estimation adam. It is basically it is general used optimizer. It will adjust learning rate during training. So and we are using the loss as a binary cross entropy. It is suitable for binary classification problems, so we are using it. And in the metrics, we are tracking the accuracy during training and evaluation. Then we are using the model.fit train and white train and epochs. We are selecting 20 epochs, and batch size of 8. So basically, I'm going to explain it. So the data, the epochs equal to 20 is like the model sees the entire training data 20 times, and the batch size is 8 is like data is split into uh, mini batches of 8 samples, each before weight updates. So means if we are creating more small batch sizes, like more updates and more generalization abilities. And then there is validation data like x test and y test. After every epoch, the model will check the performance on machine test data. So this is basically the main neural network function we have created. And then this is how it will work. Then we will run it. Then we will evaluate the loss and accuracy, and it will print the accuracy because we have created our own data set. It is showing the test accuracy 100%. If we are going to take a data set and train it on that data set, it will show some other accuracy. It will depend on the data set quality we are providing. So then we have shown the result here using the scikit library, and we are showing the confusion matrix also here. So this is the whole project we have created. This is like a proof of concept for training a model for malware detection. We can easily create a system for recognizing if a file is a malware or a benign file. So thank you.